Hi folks, it's me. So this is going to be kind of our online version of the lab. Up until now, you've talked about how to construct confidence intervals and do hypothesis testing, given that somebody had already worked out the sample mean and the sample standard deviation. And you sort of talked about how to construct those confidence intervals and do the hypothesis test by hand. You needed to use R to maybe work out a critical value or calculate a p-value, but you sort of had a formula for being able to work out those values. So this video is going to talk about how we might use R if we actually have access to the raw data. So R will go through and work out the mean and the standard deviation for you, but you can kind of do it all in one command, and this is going to walk you through it. So we'll do an example, and then that should get you set up to be able to do the problem on your own. Okay, so hopefully you can see my screen. You should be able to download this R Markdown file so that you have access to it. We're going to be working for the first example with the student sleep data. So you should be able to we have to load the open intro package, and then we're going to load in the student sleep data. So this is just how we're going to get the data in. So if I press the run button, you'll notice that student sleep pops up here. If I click it, then it turns it into a data set. So we can see that it has 110 observations of one variable. I'm just going to click on this label so you can see it. So this is the student sleep data, and see there's a list of all of these different numbers in the column hours. So they asked 110 students how many hours of sleep they got per night, and these were the answers. Okay, so I'm just going to exit out of that. So this is the data set that we're going to be working with. The function that we're going to need to be able to do this is t.test, okay? And we can use it to construct, good spelling, Emily, confidence intervals and to conduct hypothesis tests. Now, it has lots of different arguments, some of which you need all the time and some of which you don't. So the first argument here is always going to be your data. In this case, we're going to use student sleep as our data set, and then remember that you have to reference the column by using the $sign, and we'll go through that again. I know it's been a long time. If you're doing a hypothesis test, you will need to specify your alternative hypothesis. So you can say that you either want it to be two-sided, less than, or greater than. Those are your different options. And then you also need to specify the mu. Now that's going to be the mu or the mu naught that's specified under your null hypothesis. So you're going to need those two arguments if you want to conduct a hypothesis test. And then a confidence level is usually a good thing to specify as well. If you don't put in this argument, it'll just assume it's 95% confidence, but I always like to tell it explicitly so you can tell it that you want 95% confidence or 99% confidence. So those are kind of the arguments. Okay, so the first example here is to construct a confidence interval, a 95% confidence interval for the mean number of hours of sleep a student gets per night. I just want to point out this weird backslash thing. Percent signs are weird in R Markdown. If I don't have that there, you'll get an error when you knit. So if you ever decide to use a percent sign, you have to add a backslash, I don't know why I can't say that word, so that when you knit it up, you don't get an error. Okay, so I'm going to use the t.test function. For the data, I put in student sleep, that's my data set. The $sign for the number of hours to go into the number of hours, that column. Okay, so that's going to pull out that column. That's my data set. And because I'm doing a confidence interval, I don't have to specify whether it's one-sided or two-sided. Confidence intervals are always two-sided by default. And then we're going to just tell it explicitly the confidence level here as being 95%. So if I run that code, let's see what spits out. A whole bunch of stuff. Okay, so the top part is always going to tell you what would happen for a confidence hypothesis test, and we'll go through that. But right below that, you'll end up with the code here for a confidence interval. So this is your lower bound. That's the lowest value, okay, that we would expect with that level of confidence, and this is the upper value. Okay, so the confidence is already there, all in one code. So for this, I'm going to need some way to know that you ran the code and sort of know how to interpret it. So I'd like you to write just some sentence here. So I used, we are 95% confident that the true number of hours of sleep for these students is between 7.089 and 7.751. And I did it to 3 decimal places. So that would be how I would sort of interpret that confidence interval, but it's given right there. To do a hypothesis test. So maybe we were interested in whether or not students are getting enough hours of sleep, and we're going to define enough as 8 hours of sleep. Okay. So we would test the null hypothesis that the mean is 8 against the alternative that the mean is less than 8. And we're going to do it at the 95% level. So again, t.test, I'm putting in the data. So that's the hours column in the student sleep data. The alternative is going to be less because I want, it said here that we were doing it against the alternative that the mean is less than 8. So I want to do a one-tailed test, a left-tailed test. I'm going to specify the mu under the null hypothesis as being 8. That's important. I need both of these arguments in here because it's a hypothesis test, and then I'm just going to specify the confidence level. So again, run this code. You can see your confidence interval. I'm not going to interpret it there because this is a weird one-sided one. We're not going to talk about that. But what I do want you to notice here is all the stuff to do with your hypothesis test. So t is equal to minus 3.4755. That's your test statistic. Okay. This is your degrees of freedom, and that makes sense, right? There was 110 observations minus 1 gives us our degrees of freedom of 109, and it automatically will go through and work out the p-value. So I think it's formatted strangely because my window wasn't big enough, but the p-value in my case is down here. Hopefully if I rerun this, there we go, it's up on the right line. So there's your p-value all in one line of code. So if I just, you should be able to sort of write that down and interpret it. So I said here, this results in a test statistic of minus 3.4755, which I got from there. And it follows a t distribution with 109 degrees of freedom. And it corresponds to this p-value, period. Okay. Then in order to interpret it, I'm going to say, since the p-value is small, certainly less than 0.05, that's my alpha. At 95% confidence, we're going to reject the null hypothesis. And my sort of concluding sentence is that there is significant evidence to suggest that students on average are not getting 8 hours of sleep per night. And I've specified the p-value so that we know at what sort of level of significance we're making that claim. So hopefully that kind of is a good overview of the t.test function and what the output it's going to spit out. So for your problems, you're going to be working with the age at MAR data set. So you should be able to get it to load in just by pressing the play button. And if you click it, you can check it out. Okay. It came from, let me see here, the National Survey of Family Growth conducted in 2006 and 2000 or in between 2006 and 2010. And basically it's just one column, this age column, with a bunch of numbers that has, I think this was for women only, yes, in the US. So 5,000 US women specified the age they first got married. And so, yeah, so you're going to be using that data set to construct a confidence interval and to run a hypothesis test. Perfect. So hopefully that gets you set up to be able to do some things in R. Please come and see me in office hours or send me an email if you're getting weird emails or weird errors and you're not sure how to solve things. I am around and I'm happy to help.